Welcome to my very last lesson on matrices and transformations. In previous lessons, this topic we looked at finding the matrix of transformation, single matrix for successive transformations, inverse of a transformation, area scale factor, and determinant of a matrix. We also looked at a shear, stretch, isometric, and non-isometric transformations. In this lesson and the previous one, we are looking at application of these concepts in actual exam questions, and therefore I had some questions. We did the first question there, we did the other one, we did the third one there. Now in this lesson I want us to look at these two last questions, and I hope they will help you so that we master how to operate and even maybe cement the concepts of matrices and transformations all the more. These two last questions, they are much more about shear and stretch, so I might take a lot more time on those, but on the questions that regard to those particular concepts, shear and stretch. And therefore, let's begin. We have a question there. Please read to understand the question before you start drawing it out. We have the triangles ABC. We have the triangle ABC, and its image A prime, B prime, C prime. After undergoing a reflection of the line y is equals to x, we're told to find the coordinates of A prime, B prime, C prime, and the triangle there gotten, that is the image, undergoes an enlargement at center 0, 0, and scale factor is half, and to form another triangle A double prime, B double prime, C double prime. So we are told to draw the triangle A double prime, B double prime, C double prime. Another thing, we are told that the triangle ABC, that's the original triangle, is stretched with the y-axis invariant, and the scale factor is half again, to obtain A triple prime, B triple prime, and C triple prime. So we are supposed to draw the last image. Let's begin. First of all, we need to have the triangles ABC and A prime, B prime, C prime. On the screen there, you have the triangle ABC. You just need to plot the coordinates that are given. But to obtain the image of this, which is a reflection on the line y is equals to x, we first of all need to have the line y is equals to x. It's that line there. You should be able to draw it at this point. As we reflect this, I need to say a few things. One, if we are reflecting the point B, it means B will cross the middle line on the other side, equal distance, and such that the line y is equals to x is perpendicular to that line B prime. So this is what it means. This line must be perpendicular to B prime, from B to B prime, and the distance from B to the middle line should be the same as from the middle line to B prime. And that is the same thing for A and for C. So you need to have a line C to the middle line and progress to the other side such that this distance is same as the distance from the middle line to C prime. The same thing for A. And therefore you'll get a triangle like the triangle that has just appeared on the screen there. And that is the A prime, B prime, C prime. They cross the middle line, equal distance, and perpendicularly so. The coordinates of that, you can just read them. It is 6, 8, 10, 6, and 12, 10 respectively. Let's go to the next part. We're supposed to obtain a triangle A double prime, B double prime, C double prime. That's the second image, and we're told that that image is after this triangle we've just gotten has been enlarged with a scale factor of half about the origin. Let me say this also regarding that part. Since we want to get the coordinates of, say, A double prime, and the scale factor is half, the center of enlargement is 0, we should normally draw a line from the object to the center of enlargement, that is A prime to the origin, and half that way, that is, get the distance halfway of that, and halfway that distance is where the point A double prime lies. Since it's a diminished scale factor, it's a half. Therefore, we are saying that the image of this point, according to this particular transformation, reduces, or the image goes halfway the distance from the center of enlargement to the point A. And that is the same for B prime and C prime. So there's a point along this line which is halfway the distance from the center of enlargement to B prime, where the point B double prime lies. And again, there's a point from the center of enlargement to the point C prime, which is halfway that distance 0 to C prime, where C double prime lies. And therefore we have the triangle dropping there, and that's the case there. The coordinates You can always read them there. It is 3 4 for A, 5 3 for B double prime, and 6 5 for C double prime. Having said that, we go to the last part. We are told to draw a triangle. So we are told that the original triangle ABC is stretched with the y-axis invariant and the scale factor is half. I need to say a few things. One, generally a matrix of a scale factor, generally a matrix of a stretch is either K001, where K is a scale factor and this one is y-axis invariant. Or the matrix can be, if it's a stretch, it can be of 1 0 0 K, where this is the x-axis invariant and the scale factor is K. In our case, it's a y-axis invariant, the scale factor is half. So we can just put the values in this first matrix. So it will be half 0 0 1. You multiply that with the matrix of the coordinates of the triangle, and that gives us the last image: A triple prime, B triple prime, C triple prime, which is 4 6 3 10 and 5 12. Therefore we can plot that triangle and it'll be that one we have there on your screen. No doubt this has been stretched, but the stretch is not to enlarge, but is some sort of diminishing sort of stretch. So you see, originally this was a triangle. It has pushed parallel to the x-axis, if I should say that, and it has become smaller because the scale factor is half. It's less than 1. Let me say this, that ABC has been contracted to form the last image, and please notice that the y values do not change. That's why we are saying it's y-axis invariant. The coordinates we have for y for both A, B, and C were 6, 10, and 12, and those are the values we still have for the image: A double prime, B double prime, C double prime. The y's are 6, 10, and 12 respectively. So please notice that the y values do not change, and the triangle has been contracted, like made smaller. We go to the next question. Again, we have a question on the screen there. We are given coordinates of a quadrilateral. It has gone under transformation of matrix E, given there. Find the matrix and all that. Just read that to understand. And we need to begin the question. Let me begin. Now, we first of all need to get the coordinates of A prime, B prime, C prime, and D prime. And because we have the coordinates of the quadrilateral, and we have been given the matrix of transformation, we just need to pre-multiply the matrix of transformation with the coordinates of the given triangle, the given quadrilateral, and that gives us A prime, B prime, C prime, D prime, which is the image, and that's what we want, and therefore we have the coordinates there. We can plot that. Originally, this is the figure that we were given: A, B, C, D. The coordinates are given there, but after transforming this with this particular matrix, which is, I think, an enlargement with scale factor -2 about the origin, it turns over and it becomes this figure that we have here. So it goes on the other side there. Next, we look at the coordinates of the second image. The second part is we are told that the triangle we have obtained there, A prime, B prime, C prime, D prime, is transformed by a matrix S. So you're supposed to find the coordinates of A double prime, B double prime, C double prime. In other words, the image of this one under the matrix of transformation 0, 1, -1, -1, 0. And therefore, we progress as follows. We pre-multiply the coordinates of the image you just got there with the matrix we've been given to get the coordinates of the second image and ensure that your operations has been done properly. And if it's not okay, when you plot, you'll always notice there's a change, and you can always correct, but just ensure you do that. Therefore, these are coordinates, and if you plot that, we'll get it that way. So we had this one here transformed to this one, and what sort of transformation is that? Looks like reflection of the line y is equals to minus x. Y is equals to minus x is this line that cuts across that way. So that A would come over here, B would come over here, and D would come over here, and C and all that. And therefore, that's that. We go to the third part, which is obtaining the third image. And again, to obtain that image, we were told the matrix R further transforms the second image. Find the coordinates of the third image, this one here. So we pre-multiply again. This time around, we're pre-multiplying the second image, A double prime, B double prime, C double prime, D double prime, to get the third image, which is this one here. Ensure that you operate properly. And we plot that again, and it will be this one here, this one here. So that is successive transformation. The first image, second image, third image, and this was the object originally. Let's go to the next part. We're told find the matrix representing the transformation mapping the second image back to the object. Therefore, we're going to say this: let the matrix of transformation be ABCD, and we pre-multiply that with AB. All right, we pre-multiply that with AB. I just take any two coordinates of that particular object, of that particular quadrilateral. Therefore, I have the matrix ABCD pre-multiplying -4, -4, -2, -8. These are the coordinates of A prime and B prime respectively. All right, these ones here, and therefore those ones should give me the original image, the original coordinates of the object, which was -2, -2, -4, -1, and there are those ones there. After multiplying that, you'll get a 2 by 2 matrix of this order, and of this nature, sorry, and this is still the A's, and this is still the coordinates of the B's. And please notice that these two are -2, -2 respectively, and these two here are -4, -1 respectively. And therefore, we could equate them and solve the value of A. You get 0, B will be half, C will be half, D will be 0, and therefore the matrix of transformation is 0, half, half, 0. It looks like some sort of this diagram has been transformed to this one by rotating it and diminishing it. It's a combination of rotation and enlargement with a fractional scale factor. I think that's it. Then we go to the next part where we are told the point ABC are vertices of triangle ABC. The triangle undergoes a shear a shear of a factor 3 parallel to the x-axis to determine the coordinates of A, B, and C. That is the image of ABC. So I'll say this. Normally, the matrix for a shear would be either this one here, that is 1K01 for x-axis invariant, or 10K1 for y-axis invariant. Please ensure you master these things. We have 1K01 for x-axis invariant and the other one there. Now, when you have done the shear and obtained the image, you can always cross-check your work because of how the object and image normally relate. For shear, we said in a previous lesson that the area is never changing, never changes. And let's see the image that I give a lot more about that. Let's look at it. This is the matrix, therefore, because we are doing x-axis parallel to x-axis, which is the same as x-axis invariant. So we just replace k with 3. So the matrix is exactly the same way, only that the scale factor, since the scale factor is 3, we replace k with 3, and it becomes 1301. We multiply that with the coordinates of the triangle that we were given, and that gives us the coordinates of the triangle that we want, which is that one there. Now, x-axis invariant, that means the coordinates will appear like that, and just in case, yeah, we draw it, it will be ABC, that one there, and the object will be that particular one there. Does it look parallel to the x-axis? I think it does. It just looks like we are moving this way parallel to the x-axis, and yeah, and is it x-axis invariant? Yeah, the point B was the only point that was on the x-axis, and it has not changed. It remains there. So that justifies our point. These are shear of scale factor 3 parallel to x-axis, or if you like, invariant to the x-axis. And the coordinates are given there. We have the point B is this one here, the point A, the point C. Having said that, I have come to the end of my series of lessons on matrices of transformation. I hope you find all of this helpful. Please share with as many students or even other teachers as possible. I hope it helps someone. Always like, share, and subscribe. Thank you.